This is Solving Systems of Equations by Elimination Part 2. If we're going to eliminate one of these variables, I look here at this x and I think if I could just multiply maybe by -2, that's going to help me eliminate the x. So multiply by -2 is going to give me this equation here. The -2x and 2x cancel, and coincidentally those cancel also, which is just going to give me this statement 0 equals 7. This is a special case. This is the situation where the variable has canceled out and we are left with a false statement. This means that there is no solution and therefore the system is inconsistent. If we had graphed these, we would have seen that the lines were parallel. So variable cancels out, false statement, that means no solution, and therefore the system is inconsistent. If I look here, thinking about multiplying this by 2 would make this become a +6, would cancel out with this -6. And when I do that, I get this equation, and when I try to add these up, not only do the x's cancel, the y's cancel, the 10's cancel, I am left with this statement, 0 equals 0. This is the case where the variable has canceled out and I'm left with a true statement. That means this is a dependent system, and we're going to need to write our solution as x comma y, where y is written as an expression in terms of x. Now that sounds kind of weird, but this is what we have to do. We need to take one of these two equations. It doesn't matter which one, because if it's a dependent system, that means these two lines are actually the same line. So I'm just taking the top one. I'm going to rewrite this one for y. Start by subtracting 3x from both sides. Then I'm going to divide everything by 4, and this is my equation for y. Now we're going to do our ordered pair as x comma y, but the y needs to be written as an expression in terms of x. That expression right there is an expression in terms of x. So in place of y right here, we're going to put this -3/4 x plus 5/4. That means any point that fits this criteria is going to work back up in here. You know, let x be 1. If x were 1, put 1 in here for x. -3/4 times 1 is -3/4, plus 5/4 is 2/4, which is the point 1/2. That means if I put 1, 1/2 into both of these equations, I will get a true statement. This is not the only point. Any point I put in for x and then find its partner y using this equation will be a solution to this, because our solution here is infinite points that fit that criteria. Let's look at another one like that. Let's look at this. You see this being x. Perhaps if I multiply by -2, I can get things to cancel out. I get this equation. My x's cancel, my y's cancel, the 4's cancel, you're left with 0 equals 0. Same situation as a minute ago. We have a dependent system because we had a true statement here. The variables canceled out and we have a true statement. Therefore, we need to find an expression for y. That means we need to take either one of these equations and solve for y. Well, this would be the easiest one to do. So I bring this down here. All I have to do is subtract x from both sides, and this is my expression for y. Our ordered pair is x comma y, but instead of y, we're going to use this expression right here. So this is our solution. Any pair that would fit this criteria will be a solution to the system. So pretend x is 1. If x were 1, put -1 in it, put 1 in here, which creates -1 plus 2 is 1. That means put 1, 1 into both equations, you get a true statement. We could generate an infinite number of points by doing this very same thing. Pick a value for x, let's say 5. Plug it in, -5 plus 2 gives me -3. If I put 5, -3 in for x and y in both equations, I get a true statement. I could do that forever. Just pick a value for x, get the appropriate partner value for y, and you will have a solution. So concluding, if the variables cancel out and there's a false statement, then that means you have no solution and the system is inconsistent. That's as far as you have to go, no solution. However, if the variables cancel out and you're left with a true statement, the solution is called infinite points, but they need to be written as an ordered pair, x comma y, where the y is really an expression written in terms of x. This is a dependent system.